Hello students, greetings of the day. With completion of topics, unit and dimensions, now we are in a position to assess ourselves. For this purpose, I have prepared a list of questions so that you may check how much you can score. But at this point, remember one thing very clearly. Generally, students do mistake because if he or she is preparing for NEET, they do not attempt the question that has come in JEE and vice versa. Never do this kind of mistake because a lot questions are there which may come in both the exams. So do remember this thing very carefully and best of luck. Let us start. In first question, it is asking for unit of Stephen's constant sigma. Now if you can recall, Stephen's constant appears in the formula for radiation. Here I am writing the formula delta Q by delta T is equal to sigma A T to the power 4. Here sigma is Stephen's constant, A is area and T is temperature in Kelvin. Right? Now we have to write unit of sigma. So sigma is equal to, it can be written as delta Q upon delta T, which is power, rate of flow of energy, upon area T to the power 4 in denominator. So let us write now, this is power term. Power is energy upon time. So let us write the unit energy upon time, that is watt, upon area, which is meter square, Kelvin to the power 4. Now you can check your options. Which option is this? Watt per meter square, Kelvin to the power minus 4. This is option number 3. So option number 3 is correct. Move to the next question. It is saying joule second is the unit of. 4 options are provided. One is work. Now we know work is not having the unit joule second because work itself is joule. Next is momentum. Now momentum is force into time, that is impulse. So this also won't be joule second. Third one is pressure. Pressure we know that is force upon area. This also cannot be correct. The fourth is angular momentum. Now if you can recall the formula, torque dt, that is angular impulse, it is equal to change in angular momentum. So from here we can say that unit of angular momentum must be the same as equal to angular impulse, right? And what is angular impulse? This can be written as joule second because torque is force into distance. This is the same unit as joule multiplied with time. So this fourth option would be correct. Move to the next one, question number 3. Now it is asking the unit of thermal conductivity is. Again we have to recall the formula for thermal conductivity, what it would be. I am writing here formula for conduction of heat, that is delta Q upon delta T is equal to K A change in temperature upon length. I think you all must be able to recall this. So K can be written as, this delta Q by delta T is energy upon time. So it is a power term. Delta Q upon delta T. In denominator it would be area multiplied with temperature difference, and in numerator this is L here. So just write the units now. Unit for K, delta Q by delta T is watt. This is length term, so it has to be meter, but in denominator area is there, so 1 meter would get cancelled, that is meter here, and then delta T, which is change of temperature, Kelvin. So now you can check the options. This is watt per meter per Kelvin. This option number 4 is the same. Next is question number 4. Of the following quantities, which one has dimensions different from the remaining 3? First is energy per unit volume. This is energy upon volume. Okay, let us see the next one. That is force per unit area. Now if you write energy as force multiplied with distance and volume as area multiplied with distance, we would get force per unit area. That is the second option. So 1 and 2 are same. Unit wise they are the same. Third is product of voltage and charge. What is voltage multiplied with charge? Again this is energy per unit volume. So this is equal to the first only. Now fourth option is angular momentum per unit mass. Angular momentum if you write, that is mvr divided by mass. This got cancelled, it is only V into R. This cannot be equal to energy per unit volume, because in energy per unit volume dependence of mass is there, and here in fourth option there is no mass term involved. So this fourth option is the physical quantity which has dimension different from the remaining three. Let's proceed further. Question number 5. The dimensions of half epsilon naught E square, where epsilon naught is permittivity of free space and E is electric field. Now can you remember what is this quantity half epsilon naught E square? If you can remember electromagnetic wave, this term appears as electrostatic energy per unit volume. Electrostatic energy per unit volume. So it is actually an energy term divided by volume. If we write the dimensional formula, that would be, for energy it is ml2 t minus 2 upon volume, which is L cube. That would be ml minus 1 t minus 2. Now check out our options. ml minus 1 t minus 2. This seems correct. Third one. Come to this question number 6. As you can see, in these many years and these many exams it has appeared. The equation of state of some gases can be expressed as P plus A upon V square multiplied with V minus B is equal to RT. Now ideal gas equation we all know, that is PV is equal to nRT, and here one term is there A upon V square, that is added to P, another term B is there which is subtracted from V. So this is actually real gas equation, right? But here it is asking for dimension of A. So if the term A upon V square is added to pressure, what does it mean? Remember the thing I had said in earlier class, that if two terms are to be added, they must be having the same dimension. So now we can say that dimension of P has to be equal to dimension of A upon V square. Now we know dimension of P, that is pressure. Pressure is force upon area. Force is ml t minus 2 upon area, that is L square. If we multiply with this dimension of V square, that would be L to the power 6. So this will give you dimension of A. Now if we write it collectively, that would be m L to the power 5 t to the power minus 2, and this is the option number ml5 t minus 2 1. So option 1 is correct. This I think is very popular among examiners because so many times it has come in your exams. Next, come to question number 7. If dimensions of a physical quantity are given by m to the power a, L to the power b, t to the power c, then physical quantity will be. Now we have to check each of the options. For force, what is the dimensional formula for force? It is mlt minus 2. So check whether the given option is correct. No, because it is saying a is equal to 0 and m is having power a. So this cannot be force. This is not correct. Next is pressure. Now write dimensional formula for pressure. That would be force upon area. So this is ml t minus 2 upon area. If we write the dimension, it would be ml minus 1 t minus 2. Now check whether this is correct. Yes, it seems to be correct because value of a is 1, value of b is minus 1 and value of c is minus 2. So this one is correct. Now there is no need to check further option 3 and option 4. Come to the question number 8. A quantity x is given by epsilon naught L delta V upon delta T, where epsilon naught is permittivity of free space, L is length, delta V is potential difference and delta T is time interval. The dimensional formula for x is the same as that of. Now we have to check dimensional formula of x. That is equal to dimensions of epsilon naught L delta V upon delta T. Let us first write dimensions of epsilon naught. This can be written with the help of Coulomb's force. So here I am doing my rough work. F can be written as Coulomb's force 1 upon 4 pi epsilon naught Q1 Q2 upon R square. From here we can write dimension of epsilon naught, that would be Q1 Q2 upon F R square. These two are product of charges, so it would be A square T square. F into R square. F is mLT minus 2 multiplied with L square, so that would be mL3T minus 2. This is dimensional formula for epsilon naught. Now substitute here the value in expression for x, that would be A square T square upon mL cube T minus 2. Then one length term is there, so 1L here in numerator. Delta V. Delta V is potential difference, and potential difference can be written as energy upon charge. So I am writing energy mL2 T minus 2 upon charge, that is AT. And then one more T term, time here. Now let us see how many terms can get cancelled. This is one of the A got cancelled, another M got cancelled. In denominator we have T square and T minus 2. So this all got cancelled. In numerator also T square and T minus 2 got cancelled. The term remaining is L cube in numerator. In denominator also this is L cube. The only term that remains is ampere, A. So the correct option is current. So far so good. Now let us move to question number 9. Which of the following sets has different dimensions? Pressure, Young's modulus and stress. Pressure is force upon area. Young's modulus is stress upon strain, but strain is dimensionless. So again this is dimensionally equal to stress, which is equal to force upon area, and third is stress is itself, which is force upon area. So all three have same dimensions. Now check the option number 2. EMF, that is potential difference. Second term is potential difference itself, and third is electric potential. Dimensionally these all three are same. Come to the third option, heat, work and energy. As you all know, heat and work are interchangeable. They are dimensionally the same quantity. So third is also dimensionally the same. Now come to fourth. This is dipole moment, electric flux and electric field. From here itself you can check, because what is electric flux? Electric field multiplied with area. So these two cannot be having the same dimension. So from here we can say that this set has different dimensions. Next comes question number 10. The dimensions of B square upon 2 mu naught, where B is magnetic field and mu naught is magnetic permeability of vacuum is. If again you can recall from magnetism chapter, this is energy density of a magnetic field. So it has to be equal to, dimensionally it has to be equal to energy mL2 T minus 2 upon volume, which is L cube. Finally we got mL minus 1 T minus 2. Which option is this? Option number 2. In one of the question earlier, it was asking for 1 by 2 epsilon naught E square. That was energy density for electric field, and this is energy density for magnetic field. Let's move now. Next question is the dimension of stopping potential V naught in photoelectric effect in units of Planck constant h, speed of light c, gravitational constant g and ampere A is. Let us assume that V naught depends on h, c, g and A as, I am assuming the dependence V is proportional to h to the power A to the power B, this A is current, G to the power C and C to the power D. Now to solve, we must be knowing dimensional formula of Planck's constant, gravitational constant. Speed of light is very easy to write, that is Lt minus 1, and A is ampere itself. So let us write here. In your rough work you can do this. Write dimensional formula for H. You can use the formula E is equal to h nu, and you would get dimensional formula for H is m L2 T minus 1. For G, it would be m minus 1 L cube T minus 2. For C, this is velocity term, so very common one, L T minus 1. Now if you substitute here the values, dimensional formula for V is energy upon charge. So that has to be m L2 T minus 2 upon charge, which is AT, is equal to h to the power a, that leads to ml square t minus 1, this whole to the power a to the power b, g is m minus 1 l cube t minus 2, this whole to the power c, and l t minus 1 to the power d. I have separated this, it is our rough work. Now compare the results from left hand side and right hand side. So on comparing we can write power of m is 1 here on left hand side. So that is 1 is equal to, on right hand side it is a minus c. Compare powers of L, that would be on left hand side it is 2, on right hand side it is 2a plus 3c plus d. Now compare powers of t, on left hand side this is minus 3 is equal to, on right hand side this is minus a, minus 2c and minus d. For a it would be on left hand side is minus 1 is equal to, on right hand side this is b. So b directly we got, that is equal to minus 1. Now we have 4 equations and 4 unknowns. So on solving the result would be, directly I am writing these results because you can solve this very easily. 4 simple equations. On solving you would get a is equal to 0, b is equal to minus 1, you can see here itself, c is equal to minus 1 and d is equal to 5. Now check out your options. How is it appearing here? Which option is correct? H is having power 0, A is having power minus 1, G minus 1 and C 5. This seems option number 3. That is correct. Now come to question number 12. A quantity is given by F is equal to, this is under root hc to the power 5 upon G, where c is speed of light, g is universal gravitational constant and h is Planck's constant. It is asking for dimension of F. Now see, this is h c to the power 5 upon g. We can use the earlier result in which I had written dimension of h is m L2 t minus 1, c is L t minus 1 and g is m minus 1 L cube t minus 2. Simply substitute these and then you would get F is equal to, this whole is having power 1 by 2 and inside we have to write H, that is m L2 t minus 1. Then power of C is 5. So it has to be written L5 t minus 5 upon G. G is m minus 1 L cube t minus 2. If you solve this now, that would come as m square, here this is L cube, so 3 power got cancelled, this is L to the power 4. For t it is minus 2 here, so this would be t to the power minus 4 and power is 1 by 2. So it would be m L square t minus 2. Does this seem familiar to you? It is the energy term. So option number 2 is correct. Next comes question number 13. The question says a physical quantity of dimensions of length that can be formed out of c, g and e square by 4 pi epsilon naught is where c is velocity of light, g is universal constant of gravitation and e is charge. We have to check which physical quantity would be having dimension of length among the given options. Okay, so let us start with option number 1. 1 upon c square. So that would be 1 upon Lt minus 1 and square of this. So it would be L square T minus 2. Then comes G. G, if you can recall, it was M minus 1 L cube T minus 2. Can you now remember this? E square upon 4 pi epsilon naught. Does this seem familiar to you? This appears in Coulomb's force, that is 1 by 4 pi epsilon naught q1 q2 by r square. So in place of q1 q2, here it's written E square, that is product of two charges. So it is E square by 4 pi epsilon naught. If you use the formula, F is equal to 1 upon 4 pi epsilon naught E square upon r square. From here you can write E square upon 4 pi epsilon naught as F into r square. So dimensionally this is force into length square term. If you write it here dimensionally, that would be mLt minus 2 is force and then square of length. So here it would be L cube. This whole to the power 1 by 2. So check it now. What dimension it gives? L square T minus 2, and this will be M minus 1 got cancelled. This is L6 T minus 4 and power is 1 by 2. That is 1 by L square into T minus 2. In numerator it is L cube T minus 2. These two got cancelled. 2 power got cancelled, that is equal to L. So no need to check other options. Right? Understood clearly? So this is how we can use dimensional analysis to do a number of things, whether this is deducing a formula or checking a given expression. Next comes question number 14. This is somewhat different from the others we had done just now. Question says, when planet Jupiter is at a distance of 824.7 million kilometers from Earth, its angular diameter is measured to be 35.72 second of arc. Calculate the diameter of Jupiter. Now if you can recall, I had told you about the method of parallax. What that was? Now I am using that method of parallax to calculate diameter of Jupiter. This is Jupiter and it is subtending. Its diameter is subtending angle at the Earth, that is equal to, theta is provided here, it is equal to 35.72 second. Can you recall what I had said? This theta, while using the formula of parallax, always has to be written in radian. And this is diameter of Jupiter, capital D I am writing, and distance from Jupiter to Earth, that is given here. Let us write this by r. So now write here theta is equal to d upon r. From here d can be written as r into theta. Now what is r given? Distance of Jupiter from the Earth, that is 824.7 million. You must be knowing that is 10 to the power 6, but then it is given in kilometers. So to be converted to meters first, that would be 10 to the power 6 and 3 10 to the power 9. Now write theta in terms of radian. So first convert it to degree, 35.72 upon 3600. This is the value of theta in degree. Multiply with pi upon 180 to give the value in radian. On solving this, you can do your rough work, and then on solving this you would get the result, that is 1.43 into 10 to the power 8 meter. But here options are given in kilometer, so it can be written as 1.43 into 10 to the power 5 kilometer. Which option is this? Option number 4. With this, now you have practiced a lot number of different varieties of question. So I think now you should be able to solve a question if it comes in JEE or NEET from this chapter, unit and dimension.